Hello, my name is Anawat Putwanphen. Today I'm going to talk about California hospital bed capacity forecasting project. As of 19 February, 27% of reported hospitals have more than 90% of their inpatient beds occupied. 32% of reported hospitals have around 70 to 90% of their inpatient beds occupied, and only 71% have less than 70% of their beds occupied. COVID-19 still has a huge impact in availability of human hospital beds. Our agenda today will start with the project goal. Then we will talk about how dataset look like, the preprocessing process, feature engineering, modeling approach, and summary. The project goal is to create machine learning models for forecasting California's hospital bed capacity 1 month ahead. The dataset was released from US Department of Health and Human Service. These datasets contain 10,500 observations in California's only and 93 columns. The dataset was recorded in weekly level. Each row of data represented COVID-19 related information for a single hospital facility over the course of a week. The hospital information given are name, address, city, zip, state, subtypes, and types micro or metro. COVID-19 related information given, staffing levels, hospital capacity, both availability and actual usage, confirm or suspect COVID-19 cases, and etc. The dataset was stored in S3 bucket and loaded into notebook. The raw data was pre-processed to clean up some data issue before feeding into a sklearn pipeline, which include multiple steps, including feature engineering, pre-processing, fitting model, and hyperparameters tuning. First, pre-processing. Pre-processing step start with dropping in consistent columns, up rows, or incorrect report rows. For example, some rows of the data have more COVID inpatient than total inpatient, which is followed by the data definition. The next is to select only hospitals who consistently have reported COVID cases and bed capacity for the last 4 months. Next, transform our target, which is total inpatient bed usage, into multi-target column for ML model. Now our targets are ready for feature engineering. Every transformation done to feature in this project will wrap in a sklearn pipeline by using custom transformer object. First, the first feature pipeline is creating calculating column such as inpatient bed use, total COVID inpatient, average inpatient bed use since the start of the record for each hospital. Next, selecting only relevant columns for this project. Thus, generate lag feature of inpatient bed usage and COVID inpatient. The model in this project using past 5 weeks values as features. This step also calculating the last 3 weeks moving average of both inpatient bed usage and COVID inpatient. Impute missing value in each columns by the hospital median instead of the whole dataset median. Standardized continuous features and one-hot encoder categorical features. Before fitting the model, the dataset was split by time into training, validation, and test set to measure accuracy and other loss metrics. There are two modeling approaches covered in this project. The first one is to select the best candidate out of 4 models, which is lasso, a CD regressor, random forest gradient boosting, using randomized search CV to search across algorithms and hyperparameters, such as regularized coefficient, number of estimator, etc. The best model found from this approach was random forest. The next approach is stacking ensemble model. Base learner model were trained, optimized, and stacked into gradient boosting meta learner model which is also trained and optimized by randomized search series. The result? The stacking ensemble model were able to achieve the lowest MAE and RMSE when comparing to random forest model and the naive baseline model, which is to use the last week value as predictor. To summary, first, different types of machine learning model were chosen for comparison during randomized search. Random forest was selected as the base model in the and in the latter section, the stacking ensemble model was trained. The stacking ensemble model achieved lower MAE and RMSE than random forest model, and compared to the naive model, it has 19% lower MAE and 23% lower RMSE. By stacking different kind of model with meta-learner, it results in lower bias model. Better forecasting of hospital level bed capacity can help public policy maker in making better decisions. For example, school administrators who make decisions about whether to open or close the school can use the forecasting value to make the right decision. Takeaway, as of 19 February, more than 60% of hospitals still have reported more than 70% bed occupied. Even after some vaccines were given to the public since December, the hospital beds are still overwhelmed by COVID case. Preprocessing and standardizing help improve model performance, and stacking ensemble model help lower bias. The next step, first, develop classical time series model, deep learning model, or Facebook Prophet to compare the result. Second, use vaccination and COVID case forecasting data to develop a new model. Thank you for listening.